started to work on Ethereum, I read Bitcoin, and I was like, oh, that's kind of cool, but it's going to be a really large database, and nobody's going to do this proof of work thing because it's really wasteful. But I didn't know what I was talking about. So apparently people are willing to waste a bunch of electricity in order to support something that, well, that you can't take it down, right? That's kind of cool. So Ethereum came along, and I thought, oh wow, we can actually build stuff on top of it, and it's kind of like Bitcoin, but you know, it'll have a really big database too. But that really big database will have a lot of useful data for driving software applications. Show of hands here. How many people have cryptocurrency? Like, you actually have? Okay, awesome. Well, I don't know, a couple of years ago that might not be the case. Now, what about how many people own some kind of token? Okay, we're doing a little better. So next year, everyone will have tokens. That's the goal. What's hard about these talks is that, like, software like Ethereum or Oracleize or Golem is really broad, and for these platforms to actually be useful, they need to be useful for different people for different things, because in fact you can build on top of them and build something, and somebody else can build something else. So I'll try to do my best to generally cover Golem. Golem started. So Golem actually kind of started around when Ethereum started, and it started before I knew about the project. Like, I wasn't at Golem when Golem started. In fact, the guys who created Golem had a meeting with like Gavin Wood and a couple of other people, and then the meeting didn't work out, and these guys were in a restaurant in Poland on Valentine's Day, and they're like, okay, nobody needs this Ethereum stuff. Like we're going to build this other thing and call it Golem. I think what's important there is that in solving some of these problems, there are different ways to attack the problem. I think that's something important to keep in mind. Then Ethereum got built, and the team in Poland continued their interest in Ethereum because there were some novel things that can be done. A couple of the guys wrote a white paper on nano payments, and this is basically a mechanism for reducing or sort of eliminating the gas costs of paying a bunch of people by handling the payments in a random kind of round-robin way. Roll forward a bit, Ethereum launches, and it's built and running. So some team members at Ethereum continued working at the foundation. Others kind of spun off and started their own thing. What I was looking for at the time was a really good use case for Ethereum. And so that is one of the two aspects of Golem. Is on one hand, it's this worldwide global supercomputer, and on the other hand, it's a really good use case for Ethereum in order to build up all of the tools that we need so that building this software is practical for people who do not actually write Ethereum. So, what is Golem? Golem is a worldwide supercomputer. It's like Airbnb for computing. I'm sure everyone's heard that. Who all is familiar with Golem and gets the Airbnb for computing concept? Okay, okay. Less hands than I thought. But so I'll go into detail on that then in a bit and what that means. So first, a quote from Vitalik. Read this because I think it's really important. Believe it or not, this underpins the existence of all of the software that we're working on. So the software that we're working on changes the dynamics of power, right? Which is why it's also money at the same time. Vitalik goes on to say that castles are easier to build, islands are defendable, but can still be attacked. Castles are easier to destroy than to build, but elliptic curve keys are secure enough to resist state-level actors. So the software we're building is unstoppable relative to pre-existing infrastructure. That's kind of cool. It's also really dangerous. This is from Bruce Schneier, who wrote a book on cryptography a long time ago. And all of this stuff is going to be great, until it breaks. When he talks about this, he goes on to say that we should be working on this software perhaps in a riskier and more iterative way, so that perhaps the software actually fails faster. Okay, so Golem is Airbnb for computing. Golem is made up of requesters, providers, and software developers. So the requesters and the providers kind of creates a two-sided market, and somehow there's pricing on the computing, right? So a requester makes a request to execute some piece of software, and the requester wants to pay for the output of that software. And then there's this group of providers, and the providers want to commit to those requests and then execute the software and then get paid for providing the output. The software developers provide the software. So Golem isn't just about time sharing the compute resources. Golem is about executing the software and paying for the output of the software. And that's kind of important. The unofficial name for this is, requester provider protocol, where the requester and the provider figure out how much they're going to pay for that execution. And this is all done on smart contracts, on a peer-to-peer network, etc. And then the software developers provide the software. And then Golem connects everything together and is responsible for connecting the peers and providing the transaction system for facilitating this whole game. In addition to the requester provider, which would be like the Airbnb or Uber thing, we also have the application registry and the transaction framework. These are important and they're often overlooked. And because of who we have in this room, I want to go into just a little bit of detail on that. And I think this next slide may be good for that. Right. So in the current version of Golem, the first release that we're going to make on the main network, the only software is going to be a couple of open source projects for rendering. And they won't require a key for execution. So the requester and the provider can put together a transaction, and the output is rendered and delivered to the requester, and there's no transaction fee. but there will be a transaction framework in place so that later that paradigm can change. The software developer who's providing the software for this transaction can encode his own logic in order to get a fee for the use of his software on the Golem network. There's also an application registry, and what that application registry is to help the providers feel safe. So the providers essentially choose what software they want to make available for execution by the requesters, and they can only choose what software is already in the application registry. So this gives a network a sort of self-regulating mechanism.
So you didn't say about the bootstrapping the trust. You have a key problem of bootstrapping trust. Everybody should trust you for trusting everything else. So how do you bootstrap trust?
The bootstrap problem is isolated to the software developer.
No,
Software
no, it's
developer,
not. Actually, you are the intermediary.
So,
yeah, definitely wrong.
yeah. Well, let's go to questions later.
Sure.
And the whole like you're wrong or not, that's kind of not so fun. So I think there's a lot. It's more nuanced than that.
Yeah, sure.
Right. So application registry. Right. Similar to pinning content in iOS, right? Oh, sorry, IPFS. But registered on-chain, and basically, in general, everything is sort of established on the chain, on smart contracts, and then replicated in the peer-to-peer network. So the entire peer-to-peer network sort of relies on the state on chain. In other words, we're taking this whole process and we implement the peer-to-peer network and the smart contracts for it, and then we essentially outsource the consensus to Ethereum. So Ethereum handles the atomic aspects of all of the transactions. So as far as transactions for payments, we rely on Ethereum for consensus. Now, consensus on the validation of the work is a completely different problem. Okay. In addition, we're integrating the Dev P2P protocol, which Ethereum uses. There's also libp2p from IPFS, and we're not like too biased in favor against any particular protocol so much as our goal is to have something working as rapidly as possible. And so I'll get to that in the standards slide, but we're going to start with what we know can work. Right, so BRAS, end-to-end transactions with default transaction scheme. Okay. Again, in these talks, there's a lot of people here. This conference, like we're talking about replicated data, but at the same time, there's still a lot of peripheral things that are important. So a little bit on standards. This is a quick question. Like, who all here is like contributing or working on some software project in this space? Wow, it's like almost everybody. That's awesome. So, just a quick, almost opinion. Don't worry too much about standards, but worry about like working together with other people, figuring out how to like quantify or qualify like the impact of some particular standard that you're working on or some system. So. ERC20 is a great example. It's a fun example because, well, Golem didn't follow ERC20. Well, I mean, we kind of did, but we left some things out. And everybody yelled at us, but it didn't make a difference in adoption. It doesn't make a difference in traction. It doesn't make a difference in functionality. And it didn't make a difference in security. In fact, everybody came to us and they said, you have to use ERC20 or you're not secure. Except like, this is like 6 months after the DAO, and everybody totally forgot the DAO used ERC20. So don't let standards, also known as, is it bike shedding or something? Bike shedding. Like, don't let that stuff get in your way. Also realize that the standards that we're going to have, it's going to be the stuff that's secure and that scales. Like, if it's secure and it scales, you're going to get traction and it's not going to get broken. If it scales and it's not secure, it's going to get broken. If it's secure and it doesn't scale, it's going to be hard for everybody to use it. Right, and this is a bunch of fun stuff that I guess a lot of people are going to be working on as far as standards is concerned. I'm waving my hands, but I really care about what's being built in these projects. I understand, actually, yeah, these are some really cool projects being worked on. Swarm is also one of them. From my perspective, having had the awesome opportunity to work closely with a lot of people working on all of these projects, there are a lot of projects here that are all inspired by each other. And so, there may be some controversy between like the different Ethereum clients, and there's like Golem is doing one thing with the integrity of replicated computations, and then there's Oracleize, and then there's a couple of others that are all working on similar problems from different perspectives. And I think we're all going to be fairly successful, and we're going to see the good bits of all of these open source projects eventually come together to form the software that the world runs on, which is awkward, right? So we're like maybe building software that the world's going to run on. So be careful. Don't get too carried away with any one thing, because also this stuff moves really fast. So in 5 years, I don't know, like maybe we're not using JavaScript anymore. I doubt that, but before JavaScript, everybody used like ActiveX or something. So have fun. And questions about Golem?
Question. Do you have any estimate about speed?
As far as speed, that's going to depend on the use case. I mean, there's just some software applications where, actually there's a lot of software applications where you need one thing running on one computer with a ton of memory directly tied straight to the CPU. So, I mean...
And the second question is, so is the price based on the software or the hardware that's running on the node? Because for specific software, you might need a specific hardware. Do you actually adjust the price of that?
So the pricing?
Yeah, how do you choose the node that you want your software to run on?
Repeat the question, please. Repeat the question, please.
Okay, so the question is, correct me if I get this wrong. How do you price the execution? Is it relative to software? Is different software going to be priced differently? How do you price the transaction, right?
Yeah, well,
how do you price the request?
Because for maybe you might for specific software you might need to run this software on a specific hardware.
Exactly.
Different architecture,
yeah.
Or different core.
Right. So there's sort of 3 layers to the price, right? There's the cost of the actual hardware. There's the software developer, and then there may be other proprietary things. There may be licenses. There may be proprietary hardware, and that's why there's the transaction framework. Now, for the Golem network to figure out a price for the resources, for the allocation of a set of providers, in order to execute some software, that has a little bit of a bootstrapping problem. So similar to Ethereum gas cost, a little different. We will likely provide defaults and work with the providers in order to sort of create that market. However, once that's running, for that to really work and scale, the Golem client will need to historically watch what's happening in order to evaluate what the pricing should be. So the pricing can't just be like open market, but it needs to be more than that in order for it to be automated. So in other words, it's expected that Golem nodes will have some software component analyzing data metrics in order to determine equivocal price. So, and then for software, like this analysis will probably be on a per software basis, unless the software doesn't have enough volume, in which case it should be the average from the network.
Okay, but you don't give a specific solution for specific software. So let's say if you want to compute a massive algorithm or mathematical problem, you can propose someone to run this in FPGA or ASIC board.
Yeah, and then the thing is like we can't really, we have to sort of leave it up to the market to figure out the price. Daniel?
My question is whether Golem has a unified sandbox execution environment, or it can handle different virtual machines and different specifications of the software that needs to be run.
So Brass is just Docker, and then later the environment is abstracted. So the environment will be defined in the application registry as a prerequisite for the application. So hopefully we'll be able to provide native and more native environments or some kind of sandbox environment.
And how is the execution certified? Like how can we...
The execution is not certified. So it's trusted that the provider is going to run the software that is signed on the chain, with the assumption that there will be a fault if it doesn't.
Will it always be possible for provider requested to agree to not request a fee for execution, or is it always will it be cost?
Well, I mean, something like that you could do on the side anyways, but the providers aren't manually chosen. They're chosen by the algorithm. So it's not easy for a requester and a provider to sort of coordinate something. They can coordinate something through this software, by basically saying like the provider is like some large provider is going to run this piece of software, and only that provider is running that software, and the requester knows that, and so that is one case where there can be a requester-provider relationship. Yeah.
Is that selection algorithm on-chain to match requesters to other projects?
That selection algorithm is under development, but the design goal is that it can be enforced on-chain. So the selection algorithm occurs off-chain based on on-chain data, and then if there's a violation of that selection algorithm, then you can prove it on-chain, and then there's, yeah. Okay. Yeah.
I mean, is it only CPU intensive applications, or you have plans to build data intensive applications? For example, a lot of data has been stored somewhere in Swarm or IPFS.
Yeah.
And I just knew the computing instructions like do aggregation. Let's say I'm doing analytics or something like that.
Yeah. So
set that, and that particular consumer actually puts that portion of the data and does it and gives
Yeah. So the funny thing is that I think every question it asks, I could be like, yeah, Golem's going to do that, and then it's oh yeah, Golem can do anything. But the initial goals with the first few releases is to sort of build the foundation, where for certain significant use cases it can work. And it works more effectively and with more, hopefully with just as much trust as like EC2 or Azure or IBM or whatever. And then once we have the infrastructure built, we have the protocols and a framework for new software to be built in a way that it can leverage this that work. So in the later releases, we hope to have sort of like a fabric of services for routing requests to some set of data, like topological things. But that kind of stuff won't be early on. Early on will be simple tasks that can be broken down into simple subtasks. Yeah.
A rather simple question. Given you agree or disagree with the trust model, basically, are you going to offer anybody any SLAs? Or are you going to offer anything of any sort describing what a characteristic for a particular service or a particular application is on Golem?
Why would we do that?
Because when AWS put Bootstrap, they offered SLAs for everything. Initially, there was no SLAs. We just had stuff there.
So Golem is a hosting environment.
You are effectively doing SaaS and loosely speaking.
No. Well, it's
Can't say no because that's what you do, right?
It's a different form of SaaS. So it's on-demand execution of software. So
yeah,
it's
SaaS.
Yeah, no, because like that's like saying that Lambda is SaaS. Like, are you familiar with Amazon Lambda?
I wrote some of the bloody bullshit on cloud. So I sat on the ISO committee.
Right, do you know what Amazon Lambda is?
Yeah, absolutely. You can talk to any of those guys.
So it's like you like pay for the execution of a programming language.
Yeah.
Right? It's not SQL Server, it's not like you provide the code, you pay it to execute your code.
Yeah.
Right? So I'm not saying that's what Golem is. It's not that, but it's also not paying to have like SQL Server running. Like the SLA is intrinsic in each individual request. So every transaction is going to hit a set of certain providers, and yes, to increase the probability that the execution will succeed, there's redundancy, right? So we add redundancy. So we pick more providers than we need,
okay,
and we redundantly execute some of the subtasks. And in this case, we can find out which providers aren't providing the quality of service that they need. Micropayments, there's an incentive for them to actually provide the computation. Now, it's a peer-to-peer network, so there's no way we can guarantee quality of service. I mean, you can execute a request, and then, well, a third of the Golem nodes are running on AWS, and AWS goes down. Like, you're going to have to recreate your request. So, the system isn't intrinsically guaranteed and synchronous.
okay.
So, yeah.
A VHDS kind of scenario.
8 by 8 or whatever,
Yeah.
and then it's executed 8 at a time, or 16 at a time in like 2 parallel rounds. And so, if the set of providers that you have, if more of them are faulty than the redundancy, then you're going to find out in the first couple rounds, and you're only going to pay for the first couple rounds. So that's how it works. Now, it's important to point out though that that's how it works with one particular way of executing tasks. That doesn't work for machine learning. So the reality is we have our work cut out for us, because when we go to machine learning, we are going to have to come up with a different scheme for how we're going to handle the validation, because also redundancy is kind of pointless. So with machine learning, like, you have a much more Byzantine problem because, yeah, that was trickier.
What's the goal with machine learning?
Okay, so with machine learning, like a lot of times the way machine learning works is you have a whole bunch of data and you say run this algorithm on the data, and the algorithm spits out some kind of classifier, right? It spits out something that some other piece of software will load in, and then it'll read an input and tell you if the input is a valid output in a binary way or in a categorical way, right? So if I pay to have machine learning run, this machine could only run it for 10% of what I pay it to run for, and then it produces a classifier. Now, I look at that classifier, and I have no way, like, there's no fucking way for me to figure out if he ran it through all the way or not, or if I just provided bad data for the machine learning algorithm. So,
I think you could prove one half. You can actually prove that you executed on all the data in that sense. But if you gave it rubbish data, you can still do sampling. And then you can actually give the proof that randomly sampled this, and this is the probability that the data. But you need to have an oracle kind of service that he was kind of operating.
Right. So what we have to do is, in this case, we need to limit it to certain machine learning algorithms that we can distribute, and we have to figure out this weird way of like turning around this situation because the
cross-validation in that sense.
Well, the guy running the machine learning algorithm doesn't know if we provided crappy input. So maybe in a particular instance we provide crappy input. And we already know, like on our side, we actually know what the output should be, and but we have to fork that out to another provider, and it's a big mess.
It's not possible.
Yeah, well, it could be, but the other way is also to work on machine learning algorithms that maybe don't work.
You're building in black box, and this black box is no way to find out if you.
Yeah.
Analyze all the data to black box.
Just out of curiosity, anybody read the TrueBit paper?
Yeah.
Okay. Yeah. Is that awesome or what?
Yeah, it's true.
Yeah, it is.
It is.
So, yeah, check that out. And then, like, there's this part where it's like, I don't know, it's like you give him faulty work or something, but you don't tell him there's some weird thing like this. And, yeah, so we can do something with that.
So another thing that came to my mind that probably with Golem you can play a game similar to reCAPTCHA when you provide different things for execution for part of which you know what the result should be, and for the other part you don't know what the result should be, and you just don't tell which is which.
Yeah.
And Golem executes them. Well, some provider of Golem executes them, and you rank them by how they do. You give them, so you rate them by how they executed the stuff that you know how it should have been executed.
Right.
And that's entirely possible.
Yeah, so we have to figure out how to like create the threat of that game, and then if that game needs to execute it, it executes. But just having the threat there, then the usual, economic. So. Okay, last question.
Do you have a couple of use cases that you can run?
Well, it's going to be rendering, machine learning, computational chemistry, which is not unlike machine learning.
Why does it need decentralized?
Huh?
Why does it need a decentralized networking basically?
A centralized or decentralized?
A decentralized.
Why does it need a decentralized network?
Those use cases that you mentioned.
Those use cases don't need a decentralized network.
So why do they need Golem, at least the user one?
The decentralized network is just for the coordination of the providers.
Okay.
And to the software doesn't see a decentralized network. The software operates on a set of providers. So the set of providers are a subset of the decentralized network.
May I still have the last question? But
Yeah.
why are you sure that it's going to be cheaper and faster than the centralized solutions? Because the most cost
Because
go
the
not to
profits-
electricity, like with Bitcoin, the case. But here, like, why would Amazon not be able to create a more efficient solution for centralized computations and just charging a small fee?
Because in that case, yeah, I mean, somebody could do that, and then we have competition. But as of right now, nobody is even building this kind of software in the centralized space. So in the centralized space, you have like control panels, AWS, and Google, and that's it. And in the centralized space, what they do is they do it to promote their own company. It's like this sort of selfish thing. And so AWS stuff is all proprietary and only runs on AWS. And Google Cloud is proprietary and only runs on Google Cloud. And what we're doing is it's like, okay, well, we're not going to give you everything AWS or Google Cloud does, but we're going to give you something, and it runs everywhere and anywhere. And I mean, this basically means that we can go and talk to every data center that's not Google or Amazon and bring them on board. And we can do this with the software developers too. And the software developers don't want to have their customers paying what they are paying Amazon and Google. The software developers would rather have their customers pay them. And so, like, as far as functionality is concerned, I don't think the competition is relevant. I think the economics of the relationship between the software developer and the person using the software, I think that is where the cost efficiency comes in.
Cool.
Okay, thank you all for